Alright guys, today we're doing arc length and we're going to do example 2. And remember our formula for arc length is S equals the integral from a to b of the square root of 1 plus f prime of x squared dx. So the first thing we need to do, if this is our f of x, is we need to find f prime of x. So we'll take our 3/2, multiply it to the front, subtract 1, so minus 2 over 2 is going to be 1/2 times the derivative of the inside, chain rule, 2x. Alright, and this particular one we're going to do with no calculator. We're actually going to work it all the way out. Occasionally, not very often, but occasionally you will see one with no calculator. So that gives us, and then I can go ahead and cancel my 2 and my 2 here. So now I just have x times x squared plus 2 to the 1/2, and that's my derivative. Well, so it will be the integral from a to b, so from 0 to 1, of the square root of 1 plus bracket x times x squared plus 2 to the 1/2 squared dx. I'm going to clean this up as much as possible because right now it looks pretty nasty. If I square this, that just means that I write it twice, or I can just distribute it my squared. It'd be x squared times x squared plus 2. The 1/2 and the squared will actually cancel out, so it would just be x squared plus 2. So that ends up being the integral from 0 to 1, 1 plus, that's x to the 4th plus 2x squared dx. I see that, and I think, let me rewrite it. So that would be x to the 4th plus 2x squared plus 1. I can factor that. That's just x squared plus 1 squared under a square root. The square root and the squared cancel. So this is simply the integral from 0 to 1 of x squared plus 1 dx. Just remember that when you have that squared and that square root, your answer really needs to be positive because this thing is above the x-axis. And technically we're finding the area under the curve here. So this is going to be x cubed over 3 plus 1x from 0 to 1. That's 1 cubed over 3 is 1/3 plus 1 minus 0 plus 0 is 0. So that's just 1/3 plus 3/3, which is 4/3. So that one is complete. Done.